Welcome to everyone. We have around 15 participants. Thank you for joining us. I'm speaking English. I try to speak slow so that my colleague will have time to translate. Today, we are going to make terrain analysis based on a software called Global Mapper. The terrain analysis, it's a very important step that you have to do before you open any site or any IDP site. This analysis will show you how this land is done, the morphology, the slope, the rain, and let's start. Probably most of you don't have Global Mapper. It's a commercial software, a very powerful GIS software. Those who don't have Global Mapper, just contact me via Skype later on, and I will give you the link where to download it. First of all, we need to have the site identified, and usually we do it with Google Earth. Everyone knows Google Earth. And we will start from a site close to Idlib, north of Idlib, identified by Balad, by Ahmed Alian. That's the site. And that's the way that usually the site is sent to us in Gaziantep or in Amman. And so that's an easy way, everyone knows it. But we are not going to work with Google Earth. It's just to show that we have a KMZ file, a very, very normal KMZ file. We open the same KMZ file with Global Mapper. It is Mariam 1, and here is it. Automatically, it is georeference. And since we are working with Global Mapper, but as well with AutoCAD, we have to be sure that we have the right projection on Global Mapper. We need a metric projection because later on, not in this workshop, but in other workshop, we are going to use the same drawing in AutoCAD. But if we don't use the right projection from the very beginning, AutoCAD will not understand it. That's why before you start everything, you have to put the right projection. And the right projection on Global Mapper, you can go on Tool, you configure under Projection. For all Syrian, you will have UTM 37 North. This is a metric projection. This means a square is a square, and even if you open it in AutoCAD is a square, a circle is a circle and not an ellipse if you open it in AutoCAD. Okay, let's start. We open our site very easily. You go to File and you open it, like we have did it, Mariam 1. And now the very first thing that you do, you will see here an icon. With this icon, you can connect to online data. And this is the link where you can find the imagery. You can connect it. Let's first go zoom out a little bit. You connect, well, we can see where we are, imagery. Okay, that's our site. We can identify through that the nearby villages, the road. We can also take Openstreetmap. Before zoom out a little bit more. So we can Openstreetmap. And with this one, you can already start to identify the location. You can start the description where it is, how far from Idlib, how far from other cities, like that. For the general overview, it's better to work with another GIS software, which is called QuantumGIS, but for that we come next workshop. We are not going to speak about mapping in general, but we are going to speak about terrain analysis. And the power of this software is that you can download automatically the digital terrain model of this area. So where you have the slope, the elevation, and everything. If you go again on this icon, connect to the online data, you will see that you have three types of digital terrain model that you can download. You go on terrain data, and you have three types: Aster GDM, digital terrain model, SRTM 1 arc second, and SRTM 3 arc second. Normally, based on my experience, the best one is SRTM arc 1 arc second. And if you click on connect, of course, you need internet. Okay, this is a typical layout of a digital terrain model. You see the legend on the left, it shows you the elevation. With that, you can do the first activity, which would be to create the contour line. We zoom in a little bit, and we can create automatically the contour line. First, before creating the contour line, I want to say that this digital terrain model is not very much accurate, but it is kind of accurate, so you can work with it, and the option is to having nothing, so it is what you can have at the moment before even going into the field. So to do the contour line, you just have to go to Analyze, Generate Contour Line, and then here you have several options. This first one will be the name of the layer that you are going to create. I say generated contour line, 1 meter equidistance. You need to put 1 meter here. And here you have to put the resolution. If you don't need a high resolution, you can put a big number, let's say 50 in that case, 50. And then here I put again on the layer 50 so that I remember which resolution. And you see, it is going to be created. Takes some time. Okay, we have already the contour line. Take out this one. If I zoom in, that's our site. I have the contour line every 1 meter. I do the site big and red so that it's easy to solid, and we put red color so we can identify better the site. Okay, so that's our site. This is now generated contour line with a, let's say, 50-meter resolution. I can do the same, but I generate the contour line with higher resolution. Let's say I put resolution 10, then you will see the difference. 1 meter equidistance, and here I put 10. Okay. As you can see, even without going on the field, you can already understand how the terrain looks like in terms of slope. Takes some time, sorry for that. Voila. Okay, now if we compare the two contour line, this, you see a little bit, this is low resolution contour line, and this is higher resolution contour line. It is similar, of course, but the resolution is different. Now, if we put again our digital terrain model, and let's take the good contour line, you can also see the slope. If you take this icon, for example, you see path profile. Here you can see, if you want to see the slope, for example, here. Why is not coming? Oops. Sorry for that. Okay. You see here you have the slope that you can understand properly how the system works. You can also print out this, or also here you can see the slope. To have an idea why it takes so much time. Anyway, okay, here also you can see the slope, and you can even, you go through, you see where you are. Okay, but that's not that much important. Much more important is to understand now where I should make a drainage and where not. Typically, let's put this one again, and this put up there. Okay, these are our contour line. Typically, when it's rain, the water goes on the lower position, and that's a natural drain. And this software will help to find where the natural drain is going to be. And for example, in this case, we can make the watershed analysis, so-called watershed analysis, and this shows where the water goes when it rains heavily. You do like that, you just write watershed, the name of the layer. Here you have to put figures, and you have to try several times up to the point that you have a good result. And just everything is on. Again, maybe the resolution, we keep 10 resolution. And then if you don't want the computer to work too long, you can limit the analysis on the area on the screen. All data visible on the screen. So this will be short. Now you see here you have two layers. Here you can see these blue lines. This is the area where water is going to be collected during rain cases. I take out this one and this one. So it's clear. It's raining. When rain comes, goes that, and it goes down like that. And this is actually the area where you should do your drainage if you don't want to make major earthwork or excavation. And the watershed, this one, let's do it nicer. I just select the watershed, and then I right click on it. I write vertex and smooth. Okay, I deselect now. So those are the watershed. It means if we take the green one here, all the rainwater that goes in this area will be drained to this line. The same here, all the water that goes in this area will be drained on this line. So in our site, let's zoom in, we will have a major drain which is like that, and a minor one like that. So if we are going to build a drain, the best place to do the drain is here, because we follow the naturality of the soil. What does it mean? That's not the place where to put shelters, because they're going to be in the water. That's also not if you do a road, try not to cross this drain, because then you need a culvert, which is more expensive. But now, okay, we have the drain, but also important before we start to develop our sites is to see where we can put the road. And for putting the road, we need to do exactly the opposite. We have to find the highest location, so the so-called ridge line. Again, we go on analysis, and we write generate ridge line. Oops, it doesn't work because we don't have selected our digital terrain model. We select again the digital terrain model. We deselect this one. Okay, and now we do the analysis. find ridge line. Ridge line, you find again, we take the same resolution, 10 meters is fine. 10 meter. The rest we can keep it like that. We can also limit our area so it is quicker. Okay, here you see the black lines. Take out this one. Okay, here we have the top of the hill or the highest point if you want. And here we have the lowest point. So what does it mean? If you do a road here, exactly over the highest point, you don't need any type of drainage because the water will go either on the left side or on the right side. And here you need a nice drain so that all this water is going to be collected on a natural way. So that's why in that case, ideally, you would have the shelter in between the ridge line and the drain. And doing like that, you will save a lot of money and a lot of trouble because of that. And yes, we have that. But again, this digital terrain model that we have here is not that much precise. Before doing any type of drain on the soil, on the ground, you should really make a better digital terrain model. And you have two ways to make a good digital terrain model. The easiest one and the cheapest one and the quickest one is with the use of the drone. And if you don't have a drone, you can do the digital terrain model with the total station. In such a small site like Marian 1, you put the total station on one corner and you can have many points. And finally, you can have a precise digital terrain model. Now, let's go back to our site. It's here. So ideally, now we have the contour line, we have the road, and our drain. We can calculate and measure the length of the drain. Probably we don't have to make the drain from the very beginning, but at least the latest part. Important also needs to see that the water is going to cross this road. Maybe here you need to make a culvert on the existing road. Here we make a new road, and that's it. And you start to plan accordingly based on the digital terrain model. What else I want to tell you? All these shape layers can be exported in AutoCAD. Let's say you want to export the ridge line, only this one. You just have to display this one and go to File and Export. And you have to export it as a vector because it's a vector. And you choose not a shape file if you export for AutoCAD, but you choose AutoCAD extension, DVG or the XF. And then you can open it in AutoCAD. The same, and it will be georeference. The same is for the watershed. If you want to export just the watershed, the drainage, you select it, you go to File, Export, and the same, export as a vector and DGV, and you can export it for AutoCAD. As well, if you want to export it, you can export any type of layer except the imagery. You cannot export it so easily. You can also export the boundary to AutoCAD, and if you open it in AutoCAD, everything will be georeferenced. Once you have in AutoCAD this boundary, you have in AutoCAD the watershed, the drainage, and the ridge line, then it's easy work to just insert the shelter and the tents with the right distance, and then you can make your map properly considering the terrain. Now, the question will be, how big must be the drainage? what kind of drainage it should be. We are not going to speak about that today, but that's why the software as well organized or produce the watershed. Let's assume this drainage here take the water that goes in this green area. So we know the shape of the area. You just click on that and you see down here, sorry, on info. Sorry, not this one. This one, you can see the size of the area. If you have the size and you have the rain intensity and you have the type of soil, finally, you consider as well the evaporation, finally, you will be able to know how much water will have to take this drain, especially at this point, because this water with a certain delay is going to be there. You will have the slope of the drain, and to have the slope of the drain, you just need to activate the digital terrain model and, sorry, edit profile, sorry, here, path profile, okay. Let's say you make a drainage like that. This drainage has a certain profile, okay, and you can also have the slope. If you see, it gives you the slope, 14%. It depends where you want to make the drainage. And having the slope and knowing the quantity of the water that you have to drain, there is a way to dimension the drainage on the right size. Here in this point, for example, or let's say here, you will have, in this point, you will have the water coming from this area, plus the water coming from this area, plus the water coming from this area. And this drainage need to be dimensioned with the size that can host all the water. You have again the slope for that. Oh, sorry. You have the slope for that part of drainage. Let's take it again, path profile.
Sorry, Andrea, your share screen has been stopped. Can you open it again?
Now it's not working. Okay. Yes, share screen. Okay.
Now it's working. Thank you.
Now it's working again. So what I want to say, with this software, you can identify the watershed, all the area that takes the water. You can identify the natural drain. You can identify the ridge line, and you can do the contour line. And this is the basic that you need to have in advance before doing any type of site planning. If you need to make a road, for example, you have to avoid crossing drainage, because every crossing of the drainage consists on a culvert, which is expensive and make trouble. If you do a road, you don't have to be parallel to the contour line, because doing a road parallel to the contour line means you are blocking the natural drain. So if you do a road, the road must be needs to have a slope somehow, so that water can be drained along the road. Okay, let's another thing. If you are not sure of one area, let's say I'm not sure. Take away this one. Sorry.
Sorry, Andrea, to interrupt.
Yes.
Some of the colleagues is asking to repeat the last step you mentioned before stopping sharing the screen.
Okay,
Thanks.
now it was about, okay, yes, probably it was that. So the software finally shows you the watershed area. This is very important because the watershed area gives the area that takes all the water that finally will go into the drainage. I can easily identify with this icon info the size of the area you see here. Once I have identified the area and I have the rain intensity, I know how much water will fall into this area. Part of this water will be evaporated. Part of this water will be percolating into the soil, but part of the water definitely will enter into the drain, which is this one. Now, to know how big must be the drain, I need to know how much water I will have here, and as well, I need to know how is the slope of the drain from here to here. Having it doesn't work because I don't have the digital terrain model. Having that here to here, I have the slope. And you know, if I have a flat drain or almost flat drain, it must be bigger because the water will not have a big speed. So the drain will fill up easily. If you have a steep drain, the drain can be smaller because the water will have a big velocity and a lot of water can be drained in a small drainage. This is important information if you want to define the size of the drain. So with this software, you define the location of the drain and the size of the drain finally. If you are not sure, for example, you are not sure what happens with this point here. I put one point here. I don't know what happens with the water that is going to fall at this point. I call it point here, point 1. I put a new layer. I call it layer points. Okay. I put another point here. I call it point 2. The same layer. Now I can see what happens with the water that just fall at this point. I do again the watershed analysis for the points. This time I keep 10, but this time, sorry, I forgot. First, I have to select the point. I select the point. The 2 points are selected, you see here. I do again the watershed analysis. Watershed. I call the layer is called layer watershed points. I keep 10. I keep resolution 10. I keep resolution 10. This point, I have to select this option here, trace flow from selected points. Okay. Now I can exactly see what happens with the water falling over these 2 points. It takes time because I forgot to limit the analysis to the area on the screen, but we can wait a few seconds. It's working, seems that it's working. No, okay, I do it again. I do it again. I forgot, okay, analysis, generate watershed points, 10, again, 10 resolution here, 10 resolution, trace from selected points. But here, in order to be quick, I limit my analysis on the area visible on the screen. Otherwise, it will take too much time. Okay, now you can see here, I want to split. This layer contains several layers. I split it. I go to layer and I split it. Tack. Okay. Now, okay. Now you can see the water that goes into this point here, and here is just taking this direction. Also, this can be interesting because you might have a, I don't know, a water point here with a big drain or something that you need a special drain. So through this software, through the digital terrain model, you can identify where the drain should pass. Again, you might need a culvert on this road. Now, let's see, this was our analysis before any type of intervention. And let's see what now Balad did on reality. We have the site here. It's under construction. Ahmed, probably you have been there, Ahmed, because it's your organization working on that. You see, on here, we should have a drain. And in the reality, they did, where is the picture here? And they did a road. Actually, the drain is kind of coming like that. And if you see the picture, you can see most probably this is the natural drain. And it looks like real because if you go back to our analysis, it is somewhere here, the main drain coming down like that. So and the simulation seems to be okay. Also here, we go back, we have a drain. Where is the drain? Sorry, take out this one. I take the previous. Okay, and take. Okay, also we have a drain here. Somehow coming, let me see. Yes, from this area, water is going through this drain. And if you look at the picture, we have probably, it looks like a drain here, but it's not very clear. But what I want to show you with that, you do the analysis with Global Mapper, and then you compare the analysis on the field to see if this analysis is realistic or not. If the digital terrain model is realistic, where you have the drain, you should view it on the soil because you should have a sign of the drain. If you don't have any type of sign, it means the digital terrain model is not correct. And that's why, again, you go with a total station or with a drone and you do a better digital terrain model. So in this case, they put a road here, Balad put a road here, which is fine, but this road definitely needs a drainage on one side. Now, which side? If the road, let me see, the road is kind of here on the reality. So most probably this road must be elevated because it is almost on the natural drain. This road must be elevated and need to have a drain on the right side and on the left side. And here you need a culvert probably, otherwise on the longer term, this main road will be damaged. On the other hand, this road is like that. Theoretically, if we put the road on the ridge line, like that, let's take out this. If you put the road on this direction, it will be easier because the road here wouldn't be any type of drain because automatically the water would drain from its own on the right side, on the left side. Now the road is like that, straight. It means it is not ideally. This road also needs a drain, unfortunately. But fine, it's kind of on the ridge line, which is not bad. Maybe, is there any question so far? Let me see, resume. Oops, resume. I don't see.
Yeah, we have a question.
Yes, I don't see the Zoom.
Andrea in the chat.
Yes.
We have a question from Mercy Cobbs.
Yes.
Sometimes watershed analysis is not accurate. Does it due to terrain analysis accuracy?
Exactly. That's the main problem. We need a precise digital terrain model. And at the very beginning, when you identify the site, you will not have the time to go with the total station. But this at least gives you an idea, a little bit, about the slope, about the drain, about the ridge line. It is better than nothing, but right, it's not precise. But what best? What can you do better? It's better a non-precise digital terrain model than nothing. But definitely, before you start to dig and before you start to plan in detail, I think it should be mandatory to have a good digital terrain model. I don't know if I answered the question. Why I cannot see anymore the Zoom? Ah, it's here. Yes. Other question? If there is no more question,
we have Khalid Muhammad from Maran.
Yes.
And we have Ahmed Alian from Balad.
I cannot see the chat. I'm sorry for some reason.
No, they are in the participants have raised their hand.
Ah, okay.
Yeah,
please.
I am unmuting Khalid to ask his question. Please, Khalid, go ahead. Okay, then let's proceed with Ahmed Alayan.
Yes, sir.
Please, Ahmed.
This is Khalid.
Go ahead.
Okay, Andrea, thank you so much. I have a question regarding the roads elevation. As you mentioned that it's not appropriate.
I think we have Khalid talking on the Arabic channel.
Am I clear? Hello?
Yeah, I can hear you. Yes.
Okay. Regarding the roads, Andrea, you told, you said that neither we could have the roads and the let's say in the drain, this blue lines, nor on the ridge. Rather that we should construct them on the ridge, these black lines.
Yes.
So, but in most of our cases, we are forced to have the roads on some level, which is the level of the outer roads, the surrounding roads, which leads to the camp. So
yes.
So in that case, I mean, in that case, we are, how we will deal with it. I mean, how could we choose then the most proper elevation for the road?
I mean, if you can choose, if you have, let's say, an empty site and you can choose where to put the road, you put the road on the ridge line. Then you are sure that you don't need maintenance, or you need less maintenance, you don't need culvert. But of course, if there is an existing road, but then you keep the existing road, you have to adapt yourself. But you know, if you put a road in a bad location, then you need more culvert, you need more maintenance. On the longer term, it costs much more, and even the construction. But of course, sometimes you have to enter a compromise and adapt to the existing situation. Sometimes the road is existing already, so you keep it. You don't change an existing road. Here, for example, this road, you can see my screen, right? It exists. You see my screen?
Yes.
Okay. This road exists, and we are not going to change this road, for sure not. But you know, if you are building up all this site, you are plastering, you are covering the site, the rain will not more enter into the soil, and here you will have a lot of water coming through on the longer term, because the soil is going to be compressed, and here you will have erosion most probably. It means you will have, at one point you will have to repair the road. Maybe it's not you, but the authority, I don't know. But okay, but what I want to tell you, you are not going to move this road, and this as well, it exists. So you keep this road, but here, for example, in this area, at the very beginning, there was nothing. So ideally, you do a road like that. If the digital terrain model is correct. Of course, before doing like that, you check the digital terrain model. You need a correct digital terrain model. If you do the road like that, you can be sure that you don't need any culvert and you don't need any drainage. Just you don't need to elevate the road because it is already elevated. Did I answer your question?
He wrote in the chat box here.
I cannot read. Let me see.
I can read. I'm helping you.
Yes.
Okay, we have also Ahmed Alayan.
Yeah.
Please, Ahmed, go ahead.
Yeah, sure. Thank you, Andre, for this explanation. So what I understood from the bridge lines, so we have to follow these bridge lines to design our roads, right?
Ideally,
I mean, like,
ideally.
Yeah, exactly. This is one of the concerns that also I support Khaled. Like sometimes we can't construct 100%
Sure
what it shows, you know.
And sometimes, sorry to interrupt, the ridge line, it may be full of curves. It doesn't make sense to make so many curves. Then you need to find a compromise. Try to find the best solution. Yes, go ahead.
Yeah. Another question for the water lines. So for this joint that consists of 3 lines, yes. As you observed from the pictures, that we have cross road, you know, like as a minor road. So would you recommend to be in this location? Because I'm just trying to connect the picture at Google Global Mapper. So the minor road is basically on this joint, based on this joint. So would you recommend this one or not?
You mean you see my mouse? You mean this area?
The one above. The one above. Yeah, here.
I mean, the question. So here you have existing road, right?
Yeah, I'm talking about the middle of the location.
This one.
No, to the right. The middle of the location of Mariam.
Middle of the
yes,
sorry,
here. Yes, here.
Here. Okay, here first we have to see if the terrain, if the digital terrain model is correct or not. Let's assume it's correct. So you will have water coming from this side and water coming from this side. Now, depending on the rainfall, the intensity of the rainfall, and depending on the type of soil, you might have a lot of water or small water, but definitely this part will have more water and probably is worth to make a drain here. Here, maybe it's not necessary to make a drain. I know, I'm so unfortunately, I don't know the area, I don't know the rainfall, and you know the situation much better, and you can decide if it's important to make a drain or not. This is your question, right?
Yes, cool. And the last one, could you just please repeat, how did you just specify the points on the map here?
Yeah, no, it's just an example. I just wanted to show you what the software can also do. If you have a special location, let's say here, or at this point here, because here for some reason you put a water let's say water tap stand or a water point, and then the soil doesn't allow you to make a soakaway, so the water must be drained, and you are not sure if this water has to be linked to this point or to this point. The software will help you to understand where the natural slope goes. You see, like that.
Yeah.
It can be any point. It can be, it depends. It just wanted to show you that depending on one point, you can see where the water is falling down.
Cool. Yeah, thank you very much.
Yes.
We have also 2 other questions in the chat.
Yes,
Mohammed from IOM is asking, is the drone watersheds lines reflecting the capacity?
Is the drone, sorry, say it again.
Is the drone watersheds lines reflecting the capacity?
So the question is if you can do a digital terrain model with a drone.
I'm just reading the question. Could you please, Mohammed, step in and maybe discuss more?
Please, Mohammed, raise your hand so we can unmute you. Choose raise hand, then we can see you and unmute you.
Okay, here we have
Can you hear me?
Yeah, please go ahead.
Thank you, Andrea. Like the question that I have, the watersheds by the blue lines.
Yes.
This blue in the map. Is it reflecting the intensity of the water, or like it's all in the same bold?
This is just based on the digital terrain model, based on the slope of the terrain. It doesn't reflect the intensity at all. It doesn't reflect the type of soil. Just if you have a, let's say, even a plastic with the same shape of the area, the water will go through this line. Now, how much water goes through the line, this of course depends on the intensity of the rainfall, type of soil, and as well evaporation. Because part of the water goes into the soil, part of the water is evaporated. But this is, we are going to do probably in August or in September a workshop how to dimension the drainage based on the rainfall, based on the type of soil and the slope. And then based on these three parameters, and you can define the size of the drainage. But this is just the location of the drainage.
Okay, Andrea, we have another question from Musama from CARE. Is the analyzing of the drain lines matching with the accurate land slope?
Again, accuracy, everything depends on the accuracy of the digital terrain model. Unfortunately, the free available digital model that you can download are not accurate, but somehow reflecting the reality. And this is the very first step. The alternative is having nothing. So between nothing and little bit, I go for little bit at the very beginning. But then on the second step, again, you go with a drone or with a total station and you make an accurate digital terrain model. And then you will have accurate watershed analysis and accurate contour line.
Thank you, Andrea. One final question from Murad Uwais. Could you please introduce yourself? Which organization, Murad?
Okay, I'm Murad Uwais from NRC. I'm working with WOSH as a project officer. So thank you, Andrea. Everything was clear, but I have one question. First of all, when I have to set my settings, based on what I can determine the contour lines and the resolution values also. The contour lines intervals.
The contour line. So let's go back to the very beginning. I take out everything except the digital terrain model and the contour line. If you go to the analyze, you can generate the contour line from here. You have to activate the digital terrain model and then you generate the contour line. And here you have several parameters. The first one will be the name of the layer that you create. Here is the interval. You can have the contour line every meter, every 10 meter, even every 10 centimeter. And the accuracy depends only on the digital terrain model. If the digital terrain model is accurate, the contour line are accurate. Then here you have the resolution. If you have a huge area, let's make an example. I take out this one. If you have a huge area like this one, let's go zoom out. You see, I have now around 5 kilometer area. So I don't need here a digital contour line of 1 meter. It will create a chaos. I can make the contour line of every 10 meters, for example. 10 meters. And 10 meters here, and here I don't need a very high resolution because I am analyzing a huge area, so 50-meter resolution would be more than enough. And in this case, the digital terrain model that I have is good enough because in such a big area, I don't need a high precision because 1 meter or 10 meter, you can even not see it on the map. You see, it's more than enough. But of course, if I zoom in a very small area, then it's a different issue. You see, with this contour line, every 10 meters, I cannot start anything. That's why I need every 1 meter and I need a higher resolution. Go back to 1 meter resolution. It's a big difference. Now with that, I can start something. With that, it's really not enough. You get the point, eh? But again, the quality depends on the quality of the digital terrain model. I go back again. If I need to analyze all this area, I go with the freely available digital terrain model on internet. I don't need to go with total station. It will take too much time anyway. I don't need this information. But if I need to make drainage, then yes, I need a total station or the drone because my drainage need to be very precise, centimeter precise. Did I answer your question?
In the chat box, he said, sure, thank you.
I think we have no further questions.
So that's
No
good. Now,
raised
before
hands.
I continue, I mean, I just wanted to show this one first, but what I want to tell you also, when you do the watershed analysis, it is important that you do not limit your analysis on your sites, but you go a little bit also around, because you might have water coming from outside into your site. Is not the case for this one, because if we go to the watershed, let me see, it's here. Yes, also for this side, you see, let's zoom in out. We have water coming from outside of the site, going into the site, and it might be a big area in another case. So that's why if you do the watershed analysis, you have to consider a little bit around the site and not limiting your site. If you go on the site with a total station and with a drone, don't limit your flying or your analysis on that, but please take the outside as well because of the watershed analysis. Now it is already 1 hour past. There is also a possibility to make the flooding analysis with this software, but flooding analysis is not going to be today. Just I want to show you, to tell you that next time there will be the flooding analysis, and we are going to consider two types of flooding analysis. One, it's caused by a river, when the river water will be increasing and going over the line of the river and flooding the site. And the second flooding analysis is causing by your drainage, which is not dimensioned properly. So it means your drainage is filled, and what happens when the drainage is filled. But it's not going to be today, because for that I need more time. Next time, in 3 weeks or 4 weeks, you will get the invitation. And maybe I was not very clear at the beginning when I was speaking about the projection. I know that most of the engineers are not working with the GIS, but with AutoCAD. That's why, again, the projection is very, very important. That's why before you start with your analysis, you need to have the right projection. Again, I go to configure and projection, and you choose UTM and 37. And why UTM and 37? I have tutorial. Most of you knows where are those tutorial, but I want to show how to find the right projection, you go to the internet. Sorry, why I cannot see internet? This is annoying me. Okay, I go to internet, and to find the right projection, there is one site, this one. Let's say you are close to Idlib. Just right. Yes.
Andrea, you should change your share screen to show what you are saying on the internet.
I don't have it. Okay.
You can only share one screen, Andrea. You have to share again.
Okay. Now let me see. Sorry, a new share. Okay, this one. Now you can see that. Share.
No.
Now?
Not yet.
Why not?
Close the first share and share another one.
I have to see how to close the first share.
From the Zoom, you go to the Zoom itself, share screen, there is a small arrow there, you choose, and then you click on share screen. And
yeah, the problem is that I have here. Now you cannot see, right?
We are seeing the global mapper still.
Now you see global mapper.
Yes.
Okay, now I cannot see. And now you see this one.
We are seeing global mapper.
You are still in global mapper?
Yes.
Okay, then I don't know why. Let's close global mapper. And now? Still global map. Now, then is stop share. Okay.
Okay.
Now share again. Which one is it? Zoom, no. Zoom, no. Is this one? Okay. Too many. Now you see my screen, right?
Yes.
Okay. Now, okay. The UTM coordinate I want to show you. It's very important that you set up your GIS software in UTM, because then you can export all the shapefile into AutoCAD. And here there is one page, coordinate converter. I would like to give this page on the chat, but I cannot do it. You just write Idlib, and then you see here the coordinate. UTM somewhere. Okay, it should be north actually, but it's 37 north. If you go somewhere else, the coordinating change. 36. You see? 37. It's very important. If you don't do that, 38. If you don't share, set up your GIS software on the right. Now you see again global mapper, right?
No, not yet. You have to stop.
Yes, it's a global mapper.
Yeah, it's not working. Yeah.
Okay. If you don't put the right UTM coordinate 37 north, you will not be able to export in AutoCAD. And this is very important, because with this software you can make nice terrain analysis, but you cannot put your shelter. It's not precise enough to put in the shelter. So that's why you export everything in AutoCAD and you draw the shelter in AutoCAD. Eventually later, you can import your AutoCAD shelter or drawing into Global Mapper back again, and you can make a nice map. In 2 weeks, we will have a workshop in Quantum GIS, and I will show you how to generate or how to create nice maps in Quantum GIS, which are including automatic legend, scale, and all overview maps and all that. But it's important that you get the point that you have to have everything in metric coordinate. And I would like to make attention to my YouTube channel, where you can find all the tutorial. What I have explained today, you can find tutorial in Arabic and in English in the internet. Can you see the internet now?
Yes, we can.
Okay. If you go to this channel, a second. It's just YouTube, Andrea Cipa, my name. You have all the video. You have the SARD workshop, but especially you have the video how to make the watershed analysis. They're short video, but they explain in detail, 4 or 5 minutes. You have the video about the metric projection. You have the video as well, how to convert the points from the total station into the digital terrain model. You have the video how to make the contour line. And as well, you have the video for the flooding analysis. But this, we are going to do it in a few weeks. And here, flooding analysis, the for flow. And in the future, you will have also video how to work with the drone and other video. Is there any question?
No hands have been raised, nothing.
So that's good. That's good. So in that case, for today, it will be enough. It's only 1 hour, but it's fine, I think. If there is no question, I really hope that this was useful. Again, if you are interested and you need the software, please contact me and I will show you how to install and where to find the software.
Thanks, Andre. That was.
Thank you very much, Andrea, for leading these discussions and for this very fruitful information. Let's, before wrapping up, let's have final, let's say, round of questions. If anyone have a question, please raise hand or type in the chat so we can go through. Yeah, we have a question from Ahmed Layan.
Yes.
Please, Ahmed, go ahead.
Yes, thank you, Muhammad. So, Andrea, for the map, as you mentioned before, it's sometimes it's not accurate or maybe updated maybe 2 or 3 years ago. So, do you think that in QGIS maybe there are some most updated maps just to make sure you know?
In QGIS, you can find updated maps. Now I show you how to do it, but as far as I know, but maybe I mistake, you cannot find better digital terrain model. Here, there is a digital terrain model, but premium context. So you need to pay for that. I have no idea. You see, you need a username and password. I have no idea how it is. I'm not subscribed. I have no idea. Maybe you can find here a better digital terrain model. But for maps and the imagery, I show you. Let's open QuantumGIS. I have it open. Yes, I have it. Do you see my screen still?
I'm still watching the picture, but yeah.
Now you have my screen. Stop share. I stop the new screen. I share again. Let me see where it is. It's this one. Okay, this is QuantumGIS.
No,
now I just import the boundary of the site. It's called Mariam 1KMZ. Add. Again, here you have to have metric projection, and in QuantumGIS you have a big palette of maps. You go on web, quick maps. All those are maps that are available. You have, for example, Bing map. This one is not working. Bing, not always the maps are. I just put it like that because it's annoying me. Okay. Okay, you have Esri. Let's start Google. First, you have Google Map. You have hybrid map. Why is not working? Google works usually. Okay, you have this one. Let's make it different. Mariam, transparent. Sorry for that. Okay, I make it sorry again. Bigger. Dash, and we do it 1, and we make it red so you can see it. Okay, that's our side. So you have Google Map, for example. Then you will have, let me see. No. All those are maps, Yandex, Openstreetmap. You have Openstreetmap standard. You have OpenStreetMap. Then you have many maps.
Yeah.
That you can choose. You can check every one. There is a tutorial how to install in QuantumGIS this plugin. It's a plugin, Quick Map Service. You can see on my YouTube channel about the tutorial. Yandex Map, another one. It's Russian, but it helps you a lot to geo-reference yourself. Plenty of maps, but like I tell you, you have a imagery, a map, but not digital terrain model.
Yeah.
Mm-hmm. And next time when we meet, I will show you how to produce nice-looking maps with QuantumGIS using these background maps.
Okay.
And of course, if some of you knows better digital terrain model, please inform me so that I can add it on the tutorial. Yes?
Thank you, Andrea. We have a question from Osama asking about the name of the YouTube channel.
Just go on YouTube, click, type Andrea Cipa, and you can find it. I have the link, but I don't know how to give it to you. Because I don't have access to the chat for some reason.
Andrea, you can go to the Zoom. Below you have icon of the chat. You click on that, and then you can have it on the right of your screen. Or double click on the main screen, and then it's going to be short, smaller.
I double click on the main screen. Let me see. I take
out. Go down to the Zoom, your Zoom.
Yes.
And then you can have icon of chat below by interpretation and
I don't have it. That's the problem, because I have the participant.
Then you have more.
More I have, yes. Meeting info, display name of annotation, hide floating, share, computer sound, optimize. No, I don't have chat.
There is an icon saying more than
yes.
You have a chat.
Okay, found.
Yeah, you are welcome.
Okay, so this is the link of the YouTube channel. On this YouTube channel, you can also you can subscribe, so you will get the information when I produce new channels. You have also the YouTube channel for QuantumGIS, how to install this plugin for the background map and imagery, Arabic and English.
Andrea, it's received now. David have shared it now. It's okay. Thank you.
Okay. Yes, I said it to privately. Okay, fine. Any other question? So in that case, I would be over. I invite you for my next tutorial, for the next workshop for sure. And then I will be concentrating on floating analysis next time and mapping with QuantumGIS.
Thanks, Andre. That was
Thank
fantastic.
You.
Really informative.
Yeah, thank you very much. Yeah.
Next week.
The cluster has shared the links here to the next sessions. I think on next Monday at the same time, you can join the second session. Sorry, please go ahead, David.
Yeah, I was just going to say that please join us next week, where we have an expert in child in emergencies, as well as the child protection subcluster. We'll be giving a session on designing camps to be children friendly and children responsive. We all hear and have drummed into us the concept of child-friendly spaces. So what does that mean? And what does a child-friendly space mean? What does it mean to have the whole campus child-friendly? So this will be an incredibly exciting session next week. I'm really looking forward to it. So please, and obviously they'll be going into a lot more detail, a lot more design and so forth, and talking about a lot of issues surrounding children in IDP camps. So please join us next week, yeah, we really look forward to you joining us.
Just something else. If some of you participants need some help on the software and whatever on site planning, do not hesitate to contact me. I will react as soon as possible, and I will take all the time to assist you, because that's our job for the moment. So please, really feel free to contact me and David for any topics related to site planning. It can be bilateral on Skype, on WhatsApp as well.
Yeah, that'd be fine. Yes, please.
Colleagues, before wrapping up, we have a question from Muhammad from SECD. Please go ahead, Muhammad.
Okay, thanks. I want, first of all, thanks for your speech, and I just want to ask about the software. How can I call Andre? It's on Skype or WhatsApp?
Skype is better. I will just put my Skype name.
Yeah.
And then just contact me after that, and then I will give you the link and everything.
Thanks very much.